Hey guys, let's go over the Stats and Probability Chapter 1 test. This is version B, taken December 9th, 2022. Question number 1. You want to explore the relationship between a work shift. When can you work? Well, you can work morning, afternoon, or evening, and the number of accidents during the different shifts. Say I worked at Jamba Juice. How many times were your fingers caught in the blender? Hope that never happened. Good thing it didn't happen to me. The number of accidents. Well, this is quantitative because maybe in the shift there were zeros, maybe there was one, someone dropped something and hit their toe. So those are numerical, and it makes sense to take averages. Question number 3. Mr. Daniel recorded the scores of each student in his class in the form of a stem and leaf table. If the passing score is 33, and all students who scored less than 33 have failed, then match the scenarios given in the first column with the correct answer. So it looks like my stem here, they don't have a key, but the key would read, this would equal 10. So in my stem, this is times 10. So 1 times 10 is in the 10s, 20s, 30s, 40s, 50s, 60s, and 70s. Okay. So question, what is the number of students who failed? So that we need a number less than 33. So 10. So I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 students who failed, and you have choices right there, right? Okay, what is the highest score? That would be a 79. And then the number of students who passed and scored the same marks. So really they're just referring to the word called the most or the mode. Number of students who passed and scored the same marks. So if I'm looking there, I see these. So this would be 40s. But let's see. Number of scores scored less than 40, sorry. That's wrong. Let's change colors. So the numbers that scored less than 40. Now it's not less than or equals to, it has to be less than 40. So 39, 31. And 31. So that would represent 3. Number of scores that are less than 40, so less than 40, but greater than 30. And then the last one, number of students who passed and scored the same marks. This one I meant to say, that is the most, or mode. So those two would be 40, because 40 is higher than 33, that's passing, and they're the same marks, so that would be 2. Okay, question number 3. Mr. Ng collected the information about the number of likes of each post to his Twitter page received. The number of likes are shown in the table. If you wanted to, you can just make a quick one, or you can make like a dot plot. I'm just going to make something really quickly. And then I'm just going to do something way out here. Let's call that 30. So I have 1, 2, 3, 4, 4. 1, 2, 3, 4. 6, 6, 7, 10, and then
That should be 40. Something way out here, right? And so then I have to make the distribution, sketch it. Snow goes over the buildings. It's going to go something like that. Okay? Well, this one we called skewed right. There is nothing to the right. So when this happens, then you want to use the median. You only use the mean when it's normal. Your curve looks like that, cut in half like a bell shape. Okay, since it is not, the median is not affected by outliers, is your correct answer there. On a recent statistics quiz, Mr. Ng found that the normal distributions of scores, which are arranged in 5-point intervals, so this would be 60, 61, 62, 63, 64, and then with the exception of the last interval, this is 6 numbers. How many students scored in the 75 to 79 range? So here's 75 to 79. There's the number of students, and that would be 10, which would be B. Students do not pass quiz if they receive lower than a 70. So I'm going to mark 70. So F for fail, P for pass. How many students did not pass? So this would be 0, 1, 2, 3, 4, 5. So this would represent 2 and 5. 2 plus 5 would give us 7. All right, let's go over that question about Philadelphia. I went into Desmos here, and capital X equals bracket, not parentheses. I'm typing out the numbers, comma, no spaces, and you know I did that correctly with 25, because it says 25 elements in the list. And then I typed in min for minimum. You can also get that from the keyboard, clicking functions, and then scrolling down. There's a bunch of things you can use in here. Mean, median, min, max, quartile, standard deviation of the population, and box plot. So I have quartile of the list, and then I went the first quartile. Median is 50% of my data, 38. Quartile X, comma 3 means the third quartile, or 75 cents, 75%, and that is the maximum. If you needed to know the mean for talking about center, if you're going to use it, we'll talk about that in a second, and standard deviation for spread. Now you can also get the range, which is the max of X minus the min of X, 36. Let's take a look at some student work here. I wanted to talk about this student work here. Could have used a ruler. I wrote that here. And they identified that it was right skewed, because this bar here from the maximum to the third quartile has a greater distance. Let's take a look at this student's work. So the graph is right skewed is correct. Outliers that did the formula, IQR is Q3 minus Q1. And then 1.5 times IQR is 12. The upper fence, which they showed here, is quartile 3 added to the 1.5 IQR, so 40 plus 12 gives you 52, and then the lower fence is quartile 1 minus 1.5 IQR, which gives you 20. So any numbers beyond 20 would have been an outlier, and any numbers past 52 would be an outlier. So the interquartile range, Q3 minus Q1 should be 8. 8 times 1.5 is 0.4, is 12 is correct. So then our only outliers are beyond 52, which is 53, 54, 58, and 61. And there they have the range. I accepted a couple of answers for this one, so they were 1 point each. If you thought these were approximately normal, you can get that if you found the mean to be around 39 and the median to be 38. So they're roughly the same, so you can say normal and then the mean, or if you said right skewed, then the best measure is median, that would have given you full credit.
Mr. Jackson's class took an end of the topic assessment. These scores are normally distributed with a mean of 83 and a standard deviation of 5. Part A, Caroline and Emily are 2 students in the class. Caroline scored a 79 and Emily scored a 90. Calculate the z-scores for each student. So I'm going to go ahead and write the formula that we need for both of these. And when you want to compare these, we're trying to compare it with a same ruler or measurement, and that is the z-score. X, the number, minus the average divided by the standard deviation. So let's go ahead and use Caroline's. Caroline has a score of 79, and the average was 83. And the standard deviation is 5. So I'm going to get negative 4/5, which is negative 0.8. Okay, over here we have Emily. Z equals 90 minus 83 divided by 5. So you will get 7/5, which is 1.4. And what does that mean? Blue, Caroline, scored below because of that minus sign. Below the class average because that's my explain word, because of a negative z-score. Or you can say, Caroline scored higher than Caroline scored below Emily's, because Emily scored this is a plus, so above the class average. My explain word, because of a positive z, because of a positive z-score.
Jingle bell, jingle bell, jingle bell rock. Jingle bells